Welcome. We're going to go ahead and attack these problems. 1, 2, 3, 4. Let's start off by simplifying in the complex field. We want to pair together the real parts and the imaginary parts. So in this case, there's only one real part, and then we have the i's that go together. So let's order or combine and pair up like terms. So we want it to be like a plus bi, where that's the real and that's the imaginary part. So that's going to be 10 for the real part, and then we got a minus 22i, and then the plus 22i. I kind of like underlining things that go together to help pair them up. So this would just be 10, negative 22 plus 22, that's just going to be 0i. So if they want it in this format, then we have it that way. Combine like terms. Next one, we're asked to plot z1 plus z2. So we need to know what these points are first before we can plot them. So here's our reals, here's our imaginaries. So z2 is going to be, for the real part, it's 2. For the imaginary part, plus 5i. For z1, we have the real part is 5, and the imaginary part is 2i. And then to plot them or add them together, we'll just do the same thing. We'll add the parts. So I'll call this z3 when we combine them. So z3 is going to be equal to the real parts, 2 plus 5 for the real parts, plus the imaginary parts. We got a 5i and a 2i. Combine these together, combine those together. So z3 is 7 plus 7i. And then we'll go ahead and look. There's 6 and 7. There's 6 and 7, real and imaginary. So that's going to be my z3 there. Next one, let's go ahead and look at the distance between these 2 points. And see if there's any easier way to do it. So I'm trying to find out what this distance is right here. Looks like we need to use the Pythagorean Theorem to treat that as a triangle. We can memorize the distance formula, but most of us have the Pythagorean Theorem memorized, so that's kind of a little bit easier in this context. So this is up and over. How far did I go up? Well, this one, let's go ahead and look at the values of z1 and z2. That should make it a little bit easier. So z1 value is equal to, the real part is 3, the imaginary part is 7, so I can see what I'm dealing with. This one right here, the real part is negative 7, and the imaginary part is 8. 8i. Looks like I forgot my imaginary scale label. So then we'll go ahead and look at, well, what's this distance right here from 7 to 8? So that distance is just 1. From this distance right here, this is a 3 to negative 7. From 3 to negative 7, that means this distance is 10. So I'll go ahead and just use the Pythagorean Theorem so I can find out this slant. All right, so that slant is going to be, and I'll just call it d for distance, is equal to the square root of this squared, 1 squared, plus the 10 squared. 1 squared plus 10 squared under the radical, that's going to equal the square root of 1 plus 100, which is equal to 101 in the square root sign. And if it wanted a decimal, then we would type that in our calculator and round to whatever place they wanted it. Our last one that we're doing here is the average idea. Average isn't too bad, but once again, we'll go ahead and do the same thing about labeling, and then we'll get it started. So if I'm averaging 2 test scores, I add those 2 test scores and I divide by 2. If I'm averaging 3 test scores, I add up the 3 test scores, then I divide by 3. So this is also called a midpoint, but it's the average idea. We're finding the average of the real parts and the average of the imaginary parts. So I need each one. So in this case, Z1 is equal to, the real part is -5 plus 1, 2, 3, 4, 4i on that one. And Z2 here is equal to, let's see, that is Z2, 9 and 6i. 9 plus 6i. So we're looking at just the average of those two. Go ahead and use some room right here. So first I'll average the reals. So the real part is -5 plus 9. Average it, so divide by 2 since there's 2 values. And this is a point in space, so I'm just going to look at it as a point right now. That's a little bit easier. Then we got the average of the other two. We got a 4i plus 6i. I'm going to go ahead and get those i's out of the way. It's just going to cause issues later, and just make that an I on the side. It's like factoring out an I. And then, let's see, there's 2 of them. So we're dividing by 2. And then this is a point in space that I'm looking at in the complex space. So we got a 4 over 2, comma, and a 10 over 2. So this midpoint is 2, comma, 5. And then they probably want us to graph it. So that would be in the complex field. So so maybe it shouldn't have been written as a point. I'm going to go ahead and just transition that over into the complex. So that would be 2 plus 5i. Now sometimes I'll kind of do it in this way as a point and then just kind of conform it back into what I need. So this is kind of like a placeholder for me to kind of help get my feeling or my stake into it. And then once I use that to kind of help me get through it, then I'll bring it back into the format that it needs to be. So 2 plus 5i. So 2 on the real scale and 5 on the imaginary. And notice that does look like it's kind of in the middle between those. If my scale was a little bit better, then it would show a little bit better. Thank you.